2025 is clearly going to be the year of the generalist robot. The first few months of this year, I've seen so many examples of generalist robots, especially from China, robots for the home, robots for the factory, etc. With every technological advancement, the real winners are those that own the operating system. Back 50, 60 years ago, when it was about whether it was Windows or the Mac or Apple operating system, and every office had Windows, and that's what made Bill Gates the super billionaire that he is. And then we saw the smartphone generation, and it was about Android or iOS, and even Windows Phone came to the party late and couldn't make it through. So the world is dominated by Android and iOS. And so the next frontier for me with AI and everything is who owns or controls the operating system of the generalist robot. Well, Google DeepMind are making their pitch for being the de facto operating system for generalist robots using Google Gemini. So we're going to take a deep dive and look at Gemini Robotics and how it brings AI into the physical world. So we look over on the Google DeepMind. What we see here is Gemini Robotics brings AI into the physical world. This is about Google DeepMind using Gemini, specifically Gemini 2.0 based models. Gemini 2.0 is the latest general standard model from Google, and to be honest, it's one of the best out there. It competes with the big boys. Sometimes it surpasses, sometimes the other ones are slightly better, but generally, Google 2.0, the Flash version, the deep research version. If you've not tried Google Gemini, especially the deep research, then check it out. It really, really is impressive. But the key thing about Gemini 2.0 is it's multi-modal, i.e. it can kind of react to seeing pictures and images from the physical world and describe them. And then you can ask it questions about what it sees, etc. And this is exactly what you want from a robot. You want a robot to be able to see and interact multimodally to the physical world around it, to hear things, to see things. And then you ask it to do something and it does it. And that's what Gemini can do. But until now, there was a gap between the virtual and the physical kind of usage of these things. Gemini Robotics plans to bring that all together. As Google says here, we are introducing 2 new AI models based on Gemini 2.0, so their standard AI model that they've got, that we might use on our computers on a regular basis, which lay the foundation for a new generation of helpful robot. Gemini Robotics is an advanced vision language, VLA, model that was built on Gemini 2. So they're not building this from the ground up. They're building it using all the research, all that billions of dollars that are going into developing Gemini as the kind of de facto AI model, that's going to compete with ChatGPT and Claude and all of that. They're using that model to power robots. And I think that's where the real advantage is. With the addition of physical actions as a new output modality for the purpose of directly controlling robots. As I said, you've already got multimodal capabilities built within Gemini 2.0. And the thing that's missing is the physical action, telling a robot to react physically in the physical world based on what it's seeing and hearing, etc. Both these models enable a variety of robots to perform a wider range of real-world tasks than ever before. I see loads of robot demonstrations on YouTube from Chinese companies, American companies, Scandinavian companies, European companies, all sorts of different robot companies pushing forward and advancing the world of the kind of humanoid generalist robot. And the point of a generalist robot is that it's general. You don't have to kind of have a job-specific robot. You can change it very quickly, and that makes it cheaper. So basically you can say, right, I want you to, cook something up in the kitchen, and it knows what to do. And it doesn't take much training to go, actually, I want you to be a car mechanic and work in the garage or work in the factory. And you're using the same robot. And basically, that robot is built in a humanoid form because the world is designed for humans. So if you want to sort of replace humans, then it makes sense that you build something that can interact with a human-built world. And hence the need or, the push for these generalist robots. But often these demonstrations I see, they're often teleoperated because they're training the robot or they've been specifically trained for that one task. What you really want is an operating system that allows the robot to just act independently and act on your natural language instructions. And that's what Gemini Robotics is striving to do, as you'll see from these videos.
We're bringing Gemini 2.0's intelligence to general-purpose robotic agents in the physical world. To be helpful, robots need to be interactive, responding live to your actions and your voice. They need to be dexterous to complete your most complex tasks. And they need to be general to understand things in your 3D world. And all of these capabilities need to work across different physical forms. We're bringing this together in Gemini Robotics, our most advanced vision language action model.
So that basically sums it up. It's an advanced vision language model that interacts with a changing world around it. As I said, many robotic demonstrations I see are based on a fixed world, whereas clearly what Gemini Robotics as an operating system is trying to do is to allow the robot to change as the world changes around it. And you'll see that in the various demonstrations.
Notice how we move the objects and the model reacts and replans on the fly.
Can you put the grapes in that clear container?
Our model's low latency means it can respond live to rapidly changing conditions and instructions.
You know, I've seen these sort of demonstrations where somebody just, drops some fruit or food on the table and then tells the robot, sort them out into the right compartments. But interestingly enough here, this guy's trying to confuse the robot by moving the compartment around the table. And then it's up to the robot to kind of recognize where that compartment or where the container that is specifically being instructed to move the objects is. What I find particularly impressive is the fact that it's doing origami and folding here.
Did you know that the word origami comes from the Japanese words ori, meaning to fold, and kami, meaning paper?
And again, you can really see the general language model being used. It'll even suggest where to put the eyes on the finished kind of origami fox. So again, it's using that multi-modal model here to recognize the various objects on the table, even though they're kind of scattered in a mess, they're lying on top of each other and stuff like that. And that's the key thing here is 1 minute could be a load of fruit and you're just saying, oh, put the bananas in the basket. Next, it can be a load of kitchen utensils here, or it can be a game of tic-tac-toe and it recognizes it. It recognizes what the X's are and what the O's, so it can play a game of tic-tac-toe with you. Noughts and crosses in the UK. And that's the key thing here. This is not an operating system that is for programming a robot for one specific task. This is an operating system that allows the robot to understand your instructions using natural language, using its multimodal capability to see and hear the physical world, using the spatial technology that has been built into it to understand that physical world, and then follow your instructions. And for me, I think that's the key thing here with an operating system for generalist robots. You don't have to reinvent the wheel in a way. Natural language models like ChatGPT, like, Gemini 2.0 with its multimodal capabilities, and the fact that they're looking to put these into sort of glasses and stuff like that so we can see the world around it and then ask a question and then it explains. You just add the kind of physicality into that. Now you've got a robot that can follow your instructions using natural language without a lot of heavy programming because of the operating system, Gemini Robotics. Many robots, that we see in the demonstrations, sometimes they're teleoperated, sometimes they're predefined. Here, the robot has not seen this before.
Can you flip the red die so that it matches the number on the green die?
Many robots can execute predefined actions, but these movements are not predefined. The robot is reasoning both about what it sees and how to move. It figures out how to make the red die match just like we asked.
Okay, you've given it instructions. It recognizes, sort out these die in a specific way. It recognizes the die on the table and then understands what you've instructed it to do. It's not seen these before, and yet it's able to kind of cope and move and physically change the objects in the physical world according to your instructions, having never seen this before, or perhaps never done this before. For me, the best demonstration is this one about basketball. By using natural language and natural language terms like slam dunk, it understands what you mean because it recognizes, oh, there's a model of a basketball game here. I understand the context of slam dunk.
Pick up the basketball and slam dunk it.
Keep in mind, these are objects the robot has never seen before. But by leveraging Gemini 2.0's understanding of concepts like basketball and slam dunks, the robot figures out the task.
So when the guy says here, can you pick up this ball and slam dunk it? It knows what you mean. It's never done this before. It's never seen this scenario before. And yet it knows what to do simply by using the Gemini Robotics language and understanding. There are loads and loads of examples of the generalization that's being utilized here. You know, the fact that the robot's not seen these objects or these scenarios before, and yet using the natural language model of Gemini 2.0 combined with the kind of spatial physicality elements, it understands what you say and then can even do generalist tasks that it's never been asked to do before. And what you want is an operating system that operates basically out of the box, as it were. And the Gemini Robotics program can perform all the steps necessary to control a robot basically right out of the box. You've got perception, state estimation, spatial understanding, planning and code generation. And that's what makes it ideal as a generalist robotic operating system. And I know other companies are developing their own operating systems for robots, specifically, you know, AI systems that can control robots. But to me, building on an existing natural language model like Gemini 2.0 that's multimodal, but adding in that kind of capability of physical elements and understanding the physical world is the ideal way to go. Because every time you update the Gemini model, you're updating the Gemini Robotics model. And Google have partnered with Aptronic Robots to kind of put this Gemini Robotics into practice and develop the next generation of humanoid robots. So a lot of those demonstrations we saw were just sort of robot arms, etc. But here we have a humanoid robot from Aptronic utilizing Gemini Robotics.
Okay, it's your turn.
What do you see on the table?
I see some colorful letter tiles on the table.
Now, could you spell me something that could be found in a deck of cards?
Okay, how about the word ace?
As I said, in all these demonstrations, Google are very transparent about this being autonomous and the speed at which it's being filmed at or played back at. So this is one-time speed. So this is real speed. So yeah, it's slow, but it is reflective of the real world. It's not sped up to make it look sleek or anything like that. And initially the response is very similar to Google's multimodal models that we've seen, you know, using the glasses and stuff like that. The Project Astra that we've seen Google demonstrate, where it can see something and then you can ask it to kind of comment on it or tell you some information about what it sees. But as I said, the key thing here is it can interact by adding in the ingredients of robotics. It can not only just see and hear the physical world, it can interact with the physical world. And here it's using that large language model to kind of work out what's on the table and then, you know, come up and answer the question. In this case, you know, create a word from a pack of cards based on these random letters. And it's gone for ace, which is quite clever, really. And notice how it's sped up there. But if you look down in the corner below my head, I just moved my head. It says autonomous 5 times. So just for the sake of the video, it just sort of speeded up because kind of we get the point. We've seen the speed at what it operates when it grabbed kind of the first letter and all of that. What I like about these robots is because they're utilizing Gemini 2.0, they can talk back to you as well. So you can have a conversation with them.
I have packed the trail mix for you.
Hey, can you pack the orange for me?
Of course. I am putting the orange in the lunch bag.
This is what I want for my robot. I want to have a general chat with my robot while it makes me a coffee and stuff like that. As you can see, this is very early days with Gemini 2.0. kind of being implemented into the Aptronic robots, but I'm interested to see where it's going to go. Anyway, I just think it's really exciting and interesting, and I love seeing all these kind of robotic demonstrations. And what's really interesting about the demonstrations that Google do here with this is that they'll always show you whether it's been speeded up, whether it's autonomous, whether it's teleoperated. There's none of these are teleoperated, but often you don't get that in a lot of really cool, slick kind of teaser videos for robotic companies. Sometimes you think, wow, that's impressive. Turns out it's teleoperated. Nothing wrong with that because it's learning about the physical world. But to me, in a way, that's the kind of mad thing, is that you're having to teach the robot about the physical world. Where with Gemini 2.0, with natural language models, with multimodal capabilities, they already understand the physical world, or at least can understand what it sees. So you just add in the ability to interact with that physical world, and you're kind of there already. So you don't have to necessarily build a robotic operating system from the ground up. AI multi-language model, especially a multimodal one, is the ideal way to power generalist robotics. Robots that you want to operate loads of different tasks and not one specific task. And I think that's the exciting thing about DeepMind's Gemini Robotics operating system. Anyway, let me know what you think in the comments down below. Do you think this is a good, interesting thing? Are you excited about this? Are you still a bit kind of meh about robots, as I know some people are? We always seem to be just not quite there on the kind of mind-blowing aspect of it. Sure, I've seen robots run really fast. I've seen robots do somersaults and all of that. But still, when it comes to just making me a cup of coffee, doing the washing up, they still seem a bit clunky. So hopefully, as I say, we'll see a lot more speeding up of the physical interaction of the world. But the understanding of the world is certainly getting there with these multi-language models like Gemini, like ChatGPT, and building robotics on top of that seems to be the best way to go. Anyway, as I said, let me know what you think down in the comments below. And if you like this video, hit the likes because I like it, YouTube likes it, and it helps people like you find content just like this. And if you're new to my channel, do me the great honor, please hit that subscribe button, toggle that notification bell, and that way you'll know when I upload videos just like this. Talking of videos just like this, why don't you check out these videos? These ones here. Thanks for watching.